Time was when humanity gazed upon the march of years, much like sailors watch the tides, inevitable, rhythmic, and beyond command. The journey from the dawn of youth to the dusk of old age was a tale told in whispers of shifting winds. A spring, breeze of childhood, giving way to the summer gusts of vigor, then easing into the crisp fall of maturity, and finally settling into the winter hush of silvered hair and fragile bones. For eons, this progression seemed as fixed as the stars. More recently, thoughts turned to softening the edges of this voyage, perhaps easing the storms of illness that darken the later chapters. Then came the notion of charting the very currents of decline, addressing each ripple of decay one by one. It loomed as a Herculean task, a labyrinth of complexity. Yet the horizon has shifted. What once appeared a tangled odyssey is revealing itself as a simpler path. Consider this. Beneath the surface of life, from the humble yeast to the scampering mouse to the human soul, there hums a shared chorus of mechanisms steering the passage of time. These conductors of existence can be tuned with a whisper, a molecule like NMN, a burst of hearty exertion, or a pause in the feast. Aging, it turns out, is not a legion of foes, but a singular force, a rogue wave, not an armada. Once this truth dawns, the revelation unfurls like a sail catching the wind. Taming the years may be less daunting than conquering a tempest like cancer. This might sound like the ravings of a dreamer, a notion too wild to anchor in reality. But history has a way of turning the absurd into the everyday. Imagine a merchant in the 17th century peering through a crude lens, marveling at the unseen world of tiny dancers he called animalcules. Antony van Leeuwenhoek's discovery of microorganisms was met with scorn. Surgeons scoffed at the idea that scrubbing their hands could save lives. Yet, with a bar of soap and a splash of water, the plague of post-surgical infections withered. A simple key unlocked a monumental door, or picture a country doctor in 1796 pressing a droplet from a cowpox sore into the arm of a boy named Jamie Thatcher. Edward Jenner's gamble, wildly reckless by today's measure, sowed the seed of vaccination. The thought of dosing someone with a sliver of sickness to fend off a greater scourge was once deemed madness, yet it blossomed into the mightiest shield medicine has forged, stretching lives across the globe. Clarity transformed the impossible into the inevitable. Today, the compass points to new frontiers. Molecules like stacks, AMPK igniters, and mTOR dampeners signal that we're navigating waters upstream of the great maladies of age. Their power to stretch the days of every creature they touch, from worms to rodents, hints at an ancient rhythm we can retune. Further along this river lies another harbor, the quiet menace of stalled cells. These are the sentinels of senescence, cells that, having exhausted their dance of division, linger like forgotten statues. In youth, cells whirl through 40 or 50 cycles in a dish before their lifelines, the telomeres fray to stubs, a boundary christened the Finch threshold after its discoverer, Leonard Finch. An enzyme called telomerase can mend those threads, a feat that earned its finders a laurel wreath of science in 2009. Yet, save for the immortal stem cells, it lies dormant to bar the gates against cancer. In 1997, a spark of wonder flickered. Telomerase slipped into skin cells, kept them spinning endlessly. When telomeres unravel, chaos creeps in. Like a rope losing its end cap, the DNA frays, and the cell mistakes it for a shattered strand. It scrambles to stitch the breach, sometimes knotting chromosomes into a tangle that unravels into malignancy during division. Safer, then, to lock the cell in stasis, a sentinel frozen by an epigenetic alarm, its guardians, the sirtuins, abandoning their posts to mend an unfixable rift. In nerves and muscles, which rarely split, this noise muddles their essence, silencing their purpose. These sentinels earn the moniker phantom cells, haunting the body though they ought to fade. In the lab, they glow a spectral green under a rare enzyme stain, a hue that deepens with age. A slice of youthful fat gleams ivory. By midlife, it's tinged with sage. In the twilight years, it's a forest dark. Their presence is a clarion call of encroaching decline. Even in scant numbers, these phantoms wreak havoc, whispering proteins called cytokines that stir inflammation and summon the body's defenders to assault its own terrain. Chronic fire. In the flesh fuels woes like heart strain, sugar sickness, and memories fade, termed flame aging for its relentless burn. Worse, these whispers can rouse nearby cells into phantoms too, a creeping shadow that may even coax tumors to rise. In mice, banishing these phantoms has spun a tale of vigor. Kidneys hum longer, hearts stand firmer, and lifespans stretch by, a fifth or more. Research from the Crescent Institute's biologists, Tara Linden and Jonas Hart, shows that purging them eases lung scars, slows eye decay, and shrinks rogue growths. Clearing the phantom fog inherited from ancestors eons past, these cellular watchdogs eventually lose their way, clogging tissues for decades. They fan flames of cancer and chaos, turning kin into fellow phantoms. Reversing their grip is a steep climb, so the sharper blade is to cut them down. Enter senolytics, compounds crafted to sweep these specters away, promising a swift renewal. Understanding. Their origin isn't mere curiosity, it's a map to better banishment. Senescence arose as a sentinel against rogue growth in our prime, halting division to thwart tumors. Yet, in later years, it turns traitor, fanning the very fires it once quelled. This paradox, dubbed twilight trade-off, reveals evolution's pragmatism. A boon in youth outweighs a bane in age, for few of our kin once survived to see it. Across 15 million years of ape lineage, survival was a sprint, not a marathon. Predators, famine, and strife culled most before the gray set in. Middle age is a modern marvel, unscripted in our ancient play. So a trick to curb cancer in the fertile years held sway, heedless of its later toll. The wilds took care of the rest. Now the script has flipped. Predators are tales for campfires, starvation a dwindling ghost. Childhood plagues retreat, birthing grows safer, and sanitation staves off contagion. Alerts outpace storms, and peace, though fragile, spreads wider. We linger longer, and our ancient code lags behind. Phantoms pile up like driftwood, tinder for infirmity. In youth, a pinch of them under a mouse's skin sparks a blaze of aging across its frame. Senolytics could be the torch to burn this driftwood away, drugs honed to trigger the demise these cells dodged. At Crescent Institute, Dr. Elias Rowan paired two agents, quercetin, plucked from apples and greens, and dasatinib, a leukemia lance. In mice, this duo carved away phantoms, stretching lives by over a third. A week's dose might rewind the clock, a decade's reprieve before the next. Injections could revive creaky joints, dimming eyes, or scarred lungs. Another ally, rapamycin, born of Easter Island soil, mutes their inflammatory cries, a gentler Human trials began in 2018, probing joint rot and eye haze. Safety and scope remain uncharted, but the promise glimmers, a tide to lift all boats. Upstream ventures, yet a bolder course beckons further upstream. Half our genome hums with ancient stowaways, line 1 wanderers, relics of scrap DNA. In youth, these rogues are tethered by chromatin and hushed by sirtuins. With age, as NAD wanes and sirtuins scatter to mend distant breaks, the chains loosen. These wanderers sing, spawning RNA that twists into DNA, leaping anew across the genome. This stirs unrest, leaking into the cell's core, where it's flagged as an invader, sparking more inflammatory gales. Studies from Haven University's Clara Sedgwick and Rochester's Nadia Volkoff suggest these unleashed wanderers hasten decay in sirtuin-weak mice. Antiretrovirals, HIV's old foes, double their days, hinting that silencing these genes with NAD boosters might hold the line. It's not the fountainhead of youth, but a dam against the flood. Immunity's vanguard in 2018, Stanford's trailblazers crafted a shield. Irradiated stem cells, paired with a booster, primed mice to hunt cancers lurking unseen. Other sentinels, PD-1. Blockers and CAR-T warriors unmask and slay malignancies, rewriting fates once sealed. If immunity can fell cancer, why not phantoms? Researchers like Tara Linden and Mateo Alvarez wager these cells hide behind protein veils. Strip them away, and the body's hounds could pounce. A future vaccine roster might add a jab against senescence, a shield for the long haul. Skeptics cry, tampering with fate, but medicine has long defied the natural order. Smallpox's fall and malaria's looming end bear witness. Aging's no sacred right, it's a foe to face. The Airbus riddle picture. A vast airship gliding toward a gleaming coast, 600 souls aboard. Its wings lack wheels, only chutes dangle below. One door creaks open, the rest are jammed. As it nears a sprawling city, a dire truth emerges. Its passengers bear a plague. It begins with weariness, then steals sight and sound, shatters bones, claws at hearts and scrambles minds. Untamed, it kills all, cruelly. You helm a nation's helm. A call crackles. One jumper could doom thousands. Each adds a grim tally. Another rings. Jets shadow the craft. Missiles primed. Fuel ebbs. The choice is yours. This moral maze, echoing a philosopher's trolley, mirrors aging's slow plague. If you'd fell the ship to spare millions, what would you wager to halt? This universal blight? No lives need spill here. Just a bold leap. A virus laced with renewal, threading every cell to defy time's march. One Foy, resetting the tapestry vaccines, mimics, and suppressors chart a vibrant course. But what if we could unweave aging's threads entirely? Cellular reprogramming, akin to a jellyfish spinning anew from scraps, holds the loom. Youth's pattern lies etched in our code, even as years pile on. Like a weathered tapestry, its hues fade, threads snag, yet the design endures beneath. DNA's 6-foot scroll packs a saga vast as a galaxy's span into a mote-sized cell. Age frays its reading, a needle skipping on a grooved disc. Two paths. Restore the tune, a sharper needle or a polished surface. In 1958, Oxford's Jonah Caldwell swapped a frog egg's core with an elder's, birthing tadpoles. In 1996, Edinburgh's Ian Trent wove Dolly the sheep from an udder's thread. Old codes sang young again. Cloning's echo fades, its lesson lingers. Aging's scratches can be smoothed. Shannon's 1948 cipher, born of noisy wires, lights the way. Data's loss is entropy's gain, but a backup restores fidelity. In cells, the egg and sperm cast the first note, the epigenome hums it through time, and the aged self hears a crackling refrain. Yet, cloning proves a pristine score endures. Shannon's trio, observer, backup, corrector, guides the quest. In 2006, Shinya Yamamoto struck gold. 4 genes, octet, clyte, soma, and myth, rewound cells to infancy, earning him a Nobel nod. These maestros could rethread the tapestry, guiding lost sirtuins home. Mice trials hum with promise. A viral trio, octet, soma, clyte, sparks nerve regrowth, restores sight, defies glaucoma's blur. Imagine, at 30, a trio of shots plants a silent sentinel, an adenovirus bearing these genes, toggled by a pill like doxycycline. At 45, a month's dose rewinds the weave. Gray fades, wounds knit, organs hum anew. A youthful pulse returns, wisdom intact. Decades later, repeat. Pills may one day supplant shots as biotech's pace quickens. The edge of tomorrow. This isn't fantasy, it's unfolding. Yamamoto's heirs tweak mice lifespans, labs chase safer threads. Questions loom. Who claims this gift? When? How? Ethics stir. Should all defy age or some? If children's futures brighten, is it duty to act? In 2018, a Chinese pioneer sparked twins resistant to HIV, igniting debate. Risk outweighed gain. Yet the act faded fast. Soon, another may weave anti-aging into a child's dawn. The horizon nears, uncharted, yes, but brimming with hope.